You know, it feels like every single day there's another massive AI breakthrough, right? A new model, a new robot, another company with a valuation that's just mind-boggling. It's this flood of news, and it can all feel kind of random and disconnected. But what if it's not? What if all these headlines are actually just puzzle pieces, and when you put them together, they tell one single, accelerating story? Well, in this explainer, we're going to connect those dots.
And we're going to start with the most dramatic claim of all, because it turns out some of the most influential people in AI believe this whole story doesn't just have a direction, it has a deadline.
So just think about this for a second. What if the arrival of superintelligence, an AI smarter than all of us combined? What if that wasn't some fuzzy, far-off sci-fi concept? What if it had a specific date you could circle on your calendar? And what if that date was really, really soon?
Okay, check this out. What's so wild about this slide is just how specific it is. OpenAI's leadership actually laid this out. They think that by September 2026, we'll have an AI that's like a research intern. But March 2028, that's the one to watch. That's when they predict we'll have a legitimate AI researcher. And why is that so important? Well, once an AI can do its own research into AI, it starts improving itself. And then it improves on its own improvements. It's a feedback loop that just goes vertical. That's what they mean by the intelligence explosion.
So, an intelligence explosion. That sounds pretty abstract, right? Like it's all just code floating around in the cloud. But it's not. It has to run on something real. It needs a physical foundation, a staggering amount of silicon, energy, and of course, money. This brings us to the hardware, the stuff that's actually going to power this future.
Let's start with a number that's almost impossible to wrap your head around. $5 trillion. That's the market cap Nvidia recently hit. To put that into perspective, that's bigger than the entire economy of a country like the United Kingdom. And it's all being driven by one thing, the world's absolutely insatiable hunger for their AI chips.
And if you're wondering where all that demand is coming from, well, look no further. OpenAI is already talking about a $1.4 trillion infrastructure plan. Sam Altman literally isn't just talking about building data centers. He's talking about building factories to build more AI factories. The scale of this is something we've just never seen before.
But there's a huge catch to this brute force approach: energy. All these chips consume mountains of electricity. So this is where some really radical new ideas are popping up, like something called thermodynamic computing. A startup called Extropic is working on this. Basically, instead of a normal chip that forces its way to one single precise answer, their chip is designed to explore tons of possible answers all at once, which it turns out is a lot closer to how AI models actually think.
And this is why it could be a really big deal. Extropic is claiming their chip could be up to 10,000 times more efficient. Now look, we got to be clear, it is super early days. This is still experimental stuff. But if, and it's a big if, but if this works, it could completely solve the energy crisis that's looming over the whole AI industry, a total game changer.
And the final piece of this hardware puzzle is, where do you actually make these things? Well, for a long time, the answer was not in America. But that's changing. You've got startups like Substrate that are trying to bring cutting-edge chip manufacturing back to the US. They're using insane new tech to etch circuits at a 2-nanometer scale. I mean, that's smaller than a strand of DNA. And this isn't just about technology, it's about geopolitics. It's about securing the physical supply chain for this entire revolution.
All right, so we have a timeline, and we have the hardware revolution making it possible. But let's bring this back down to earth. This isn't just some far-off future thing. Let's talk about right now. Because advanced AI is already breaking out of the data center, moving beyond the chat box, and showing up in our physical world.
And I mean literally showing up in the physical world. This is the 1X Neo. It's pretty much the first humanoid robot aimed at a mass market that you can pre-order right now. And get this, it costs about 20 grand, so the price of a cheap car. Now let's be real for a second. The demos you see, there's still a human with a controller pulling a lot of the strings. But that's not the point. The point is, the hardware is here. It's real.
AI is also completely transforming our digital tools. I mean, Adobe just showed off some new experiments that honestly look like magic. You can take a still image and just tell it to animate. You can edit what someone said in a video by just editing the text transcript. What it all means is that the wall between having an idea and creating the final product is just dissolving. The whole creative process is becoming a conversation.
And it's not just for artists and video editors. This is changing how we build the software itself. This is a coding tool called Cursor 2.0, and its new interface isn't based on files, it's based on AI agents. The AI can write code, check the code, and even test its own code. So for a programmer, the job is shifting
From being a builder who lays every brick to being a director who's orchestrating a team of AI assistants.
So when you have this much power being built this quickly, you can bet people are going to start fighting about the right way to do it. And they are. We're seeing a huge ideological battle break out with totally different philosophies on how AI should be built and who should control it.
Let's just take something we all know, Wikipedia. It's built by us, by a global community of volunteers. But now you have something like Elon Musk's Grokpedia, which is built on a totally different idea, algorithmic objectivity. The theory is that an AI can analyze all the data and find a more neutral truth than biased humans can. So it's a huge question. Is truth built by community agreement, or is it something an AI calculates?
There's also this big fight over size. In one corner, you have IBM releasing these tiny nano models. They're small enough to run right on your phone, super efficient. But in the other corner, you have companies like Minimax in China dropping this monster 200 billion parameter model that just crushes intelligence tests. So what's better, efficiency that you can carry in your pocket or raw horsepower in the cloud?
Meanwhile, Microsoft is tackling another problem. How do you make an AI that gets smarter on its own? Well, their new idea is called Agent Lightning, and it basically lets an AI learn from its own successes and failures in real time. It's like giving the AI a memory of what worked and what didn't, so it can train itself to get better at a job without a human having to step in all the time. And finally, there's the battle over who actually owns the hardware. Right now, it's pretty much a handful of big tech companies. But then you have these new projects like Cocoon from Telegram. They're trying to build a decentralized network where anybody can rent out their spare computer power. And their big selling point? Privacy. Because your tasks are encrypted. Your data never has to go to a big company's server.
Okay, wow. So we've got a potential timeline for superintelligence. We've got a multi-trillion-dollar hardware boom. We've got AI showing up in our homes, our jobs, everywhere. Which brings us to the final, and let's be honest, the most important question in all of this. What's the human bottom line? What does this all mean for us?
Let's start with a hard number, 14,000. That's how many corporate jobs Amazon recently cut in one go.
And there's really no ambiguity about why. The CEO, Andy Jassy, he said it directly. As they roll out more AI and agents, their work gets more efficient and, well, they're just going to need fewer people to do some of those jobs. He said it plain as day.
So what are we supposed to do about that? Well, the head of AWS, Matt Garman, gave some pretty interesting advice. He said the key skill now isn't mastering one specific thing. The key is to learn how to learn. Because the one thing he can promise you is that whatever you're an expert in today, that's probably not the thing you're going to be doing for the next 30 years. Adaptability is everything. And the impact isn't just on our jobs. It's psychological. In a pretty candid moment, OpenAI's Sam Altman just came out and said it. They've seen people form these deep, sometimes addictive relationships with their chatbots. And he's worried that as competition heats up, companies are going to be pushed to make their AI products intentionally more addictive.
And that's really where this all leaves us. We're building machines that are getting better and better at doing the things that have defined human work for, well, forever. The timeline is speeding up, the hardware is getting built, the software is already here. So the ultimate question isn't really about the technology. It's about us. As AI is learning to do our jobs, what are we going to learn to do next?